Okay, Unit 6, Day 5. In example 1, the one is to apply the transformations of tangent to graph cotangent. So these blue dots here are going to be from our parent graph tangent, where the turning point is at the origin and these 1 and -1 points are quarter way through the period, and then we have these asymptotes. Now for tangent, those are certain numbers, but since there are going to be changes here, I don't mark the x-axis for tangent yet. Next, I'm going to plot cotangent and apply this 2. So the 2, as we saw for tangent, affected the turning points. So instead of having it be 1 and -1, it would be 2 and -2. But we'll hold off on that for a second. Also, tangent and cotangent are reciprocals. So when tangent is 0, cotangent is undefined. That's why there's an asymptote along the y-axis. When tangent is 1, cotangent is 1. The reciprocal of 1 is 1. When tangent is undefined, cotangent is 0. And if I keep that pattern of here to here to here, I'd have the cotangent graph, and the asymptote will be here. But what I'm also going to do is I'm going to apply this 2 and stretch the graph up to here and down to here. And the next period, same thing. And so here is our cotangent graph. It's 0 when tangent was undefined. It's undefined when tangent was 0. And then when tangent is 1, cotangent is 1. And when tangent is -1, cotangent is -1. And here is our second period. Now, labeling the axes. The b value is 4. So 2 pi, and since tangent and cotangent have periods of pi, this will be pi over 4. That's where I got that from. Pi is the regular period divided by 4. It's now pi over 4. So from here to here, it's pi over 4. So if that's pi over 4, half of it is pi over 8, and half of that is pi over 16. 1 pi over 16, 2 pi over 16, 3 pi over 16, 4 pi over 16, 5 pi over 16, 6 pi over 16, 7 pi over 16, and 8 pi over 16. And if I go ahead and reduce the ones that I can, I get these in-between values. And so again, because we have a 2 in front, we're going to stretch the middle points to 2 and -2. So the domain is a set of all real numbers such that x is not where the asymptotes are. And the asymptotes are at every pi over 4. So not equal to every pi over 4 or every possible pi k over 4. Again, k is an integer. Up and down, the range is forever. The vertical shift. There wasn't one, or stretch, or the vertical stretch was 4, so we did that. The period is pi over 4. we did that. There wasn't a horizontal shift, and the midline stayed y equals 0. So all we had was a vertical stretch and a change in the period from pi to pi over 4. Here again, we have cotangent, but it's a flipped cotangent. Now you might think of a flipped cotangent as a tangent, and you're kind of right, but you're mostly wrong. Because cotangent, when tangent is 0, cotangent is undefined. They're different. They're different. They're similarly shaped, but they're different. So what I did first is I did the is again I started with the tangent graph, which was here, here, and here, asymptotes here and here. We're not labeling the x-axis yet, but that's the general shape of tangent. Next, I'm going to do cotangent. So whenever tangent is 0, cotangent is undefined, so here's an asymptote. When tangent is 1, cotangent is 1. When tangent is 0, so when tangent is undefined, cotangent is 0. And if I keep going with that pattern, like we did in the original previous question, we would get this shape. And here is our cotangent graph, and just cotangent, nothing else. But this cotangent graph is flipped. And so, yeah, you're right. If I take the reciprocal of 1, it's -1. The reciprocal of 0 is 0. The reciprocal of -1 is 1. And I kind of have, you're right, the shape of a tangent, but the asymptotes have been shifted over. Okay? And so if I want to draw another period for that cotangent that's been flipped, I can go back to the left 4 boxes. And so 1, 2, 3, 4, here's an asymptote. And then we have this point down here, here, and here. And here's our cotangent graph that has been flipped. Next, we're going to take that graph and shift it to the left pi over 2. Well, let's back up for a second. Our b value is 2, so our period is pi. That's the normal period for tangent and cotangent over b, and our period is pi over 2. So, here's an asymptote. Here's an asymptote. So that period is pi over 2. Half of that is pi over 4. Half of that is pi over 8. And so for the moment, we have, and then if I shift that up 1, so then this point goes up 1, this point goes up 1, this point goes up 1. And there we have, and I better show where 1 is on the graph so I don't lose any points. And so now I have a graph with a period of pi over 2. It's vertical shift of 1. Now, if I shift it to the left pi over 2, what's interesting is, yeah, this graph gets shifted over here. But remember, this thing goes on forever. So the one that's over here is going to shift, and look at it ends up right where the one that shifted to the left used to be. Because there's one over here that I didn't draw yet that shifted over, because this thing repeats over and over and over forever. And again, once you've seen one period, you've seen them all. So the domain is all real numbers except for where the asymptotes are. Again, they're at every pi over 2, as it so happens in this case. The range is up forever down and up. There is not, or there is a vertical stretch of, no, there's not. There's no vertical stretch. There's nothing in front of the cotangent. There's none. Our period is, let's correct this, it's normally pi over b, so that's pi over 2. The shift to the left is pi over 2, and so if you shift a period, you really won't see a difference. And the midline here is at y equals 1, the middle of the graph, one above the x-axis.